Welcome to our final lectures of the Advanced Power Electronics and Control. Today we are going to discuss basically the applications and we shall conclude this course formally. Now we have detailed discussions about different kind of topology and we find that actually power electronics finds its applications for the industrial usage. This is basically the switch mode power supply. Mostly it is in DC to DC converter, and the power factor correction technique or PFC, it is used in case of the AC to DC conversion, and universal import is used basically also in industrial applications for the AC to DC or DC to AC applications. Thereafter, to increase the efficiency of the converter, we go for the soft switching and that leads to the efficiency, and this area also actually the area where lot of people investigate and contribute and thus increase the more reliable product, more reliable efficiency. Uninterruptible power supplies, that is we all our computers are fitted with the UPS, and UPS is one of the major application of the power electronics. Hot sink paralleling also something, it has been used for the process control, and the motor tray application. This is a huge application, most 80% of the energy is consumed in basically the motor tray applications. Now let us take motor tray applications. This is essentially you have a 3-phase systems, and generally you will find that actually we have seen the rectifier, a different kind of rectifier, converters, dual converters, and followed by actually inverter. This is a instant kind of thing, and from that we have so many things, that is matrix converter, all those topology has been discussed. So these are basically the derivative from the this kind of DC to AC conversion techniques. Now we essentially have a typical PC power supply, that is in UPS, or maybe actually you have a huge data banks and you may have actually different kind of AC supply, you got a rectifier, they have a DC to DC converter, and you may have a DC loads, and these are maybe the storage element, data storage element, and huge power DC power supply is required. So this is one of the applications of the power electronics. Another application is definitely is that the classical inverter scheme with the PWM and some AC to DC applications, and we require a desirable DC, thus we go for the direct to indirect AC to DC to AC conversion. Now broadly what we have actually featured in, we can categorize application specific area. These are the renewable energy. Renewable energy actually benefited very much with the support of the control system and power electronics. With the increasing number of the renewable energy sources and the distributed generation, the new strategies have to be implemented for the operation and the management of the electric grid, because we have, let us say nowadays actually, except I believe the northeast whole India is connected by a single grid, and thus it has got a huge inertia, but our solar inverters has got zero inertia almost, or very low inertia compared to this actually alternator. So once you incorporate a very low inertia system with the high inertia system, we require to have a grid parity and all those things. So we require to have proper operations and the management of the electricity grid. This is one of the challenges involving, and ultimately we require to provide solution to the control and the power electronics. Power supply reliability and quality have to be improved, because problem of the power quality basically due to the switching of the power electronics converter, and thus power electronics has to clear out the mess, and it should clear it out. And definitely liberalization of the grids leads to the new management structures, because there are many stakeholders of a grid, because one may be actually the agent who is selling the actually the renewable energy, one may be a selling, one may be a consumer, another may be the protocol monitors. There are many stakeholders, and ultimately grids has to accommodate all of them. Power electronics technology plays an important role in distributed generation. Nowadays, with the penetration of the renewable energy in a distributed network, power electronics plays a very important role, and its role and all those actually solar inverters are essentially a bulk of the power electronics device. It helps to integration of the renewable energy source with the electric grid, fast evolution due to development of the first semiconductor switches and introduction of the real time controller. Its application to the current technology and the future trend in the variable wind speed turbine also has to be featured in. Power conditioning systems are used in the grid connected PV. Research and the development trends are going on with the energy storage system, because one of the problem of countries like India that actually the peak power problem, because we have a peak shortage, but unfortunately average power most of the India is more than that. So, for this reason actually we require to have a actually efficient storage element to actually shift the peak of the system. Wind turbine technology, the turbine market has been growing over the 30% over a year worldwide as well as India. It plays an important role in electricity generations. This technology is widely used in Germany and Spain, and the rate of penetrations in India is also coming high. The variable speed technology, that is 5% increase in efficiency, is quite possible because of the soft switching and the other modern power devices. Easy control of the effective and the reactive power flow, because we may have actually the fax devices that can control basically the flow of reactive power and the real power through the transmission line. So, this fax ensure that easy control of the active and the reactive power flow, and where rotors acts as a flywheel as a storage energy, and it has no leakage problem, but it has a higher cost, and most of the power electronics part actually constitutes actually 70% of the bill of material. So, this is a typical example of a wind turbine. Actually it is basically fitted to the gearbox, and you will have a doubly fed induction machine where you will feed from the stator as well as the rotor, and thus you have you may actually, if it is rotate above the synchronous speed, then both stator and rotor actually feeds power to the grid, and if it is below the synchronous speed, generally power is taken to the rotor by the rotor, and ultimately you get the difference of the power from the stator into the grid. So, this is the overall diagram of it. So, this is, you can see that there is a gearbox, thereafter it feeds the power to the stator as well as the rotor. So, this is a rotor side converter as well as the stator side converter. This is basically the stator side converter, and this is a rotor side converter. It can inject power, or it can actually take away power. It can inject the power into the rotor in the subsynchronous speed, and it can actually take out the power for the above its bed speed, and this is the function of the dual converter. So, this is called doubly fed induction motor for actually or DFIG in case of the wind energy application. So, converter feeds through the rotor winding, stator winding connected directly to the grid, and what happened basically main advantage of this topology is that since it sees only the rating of the rotor, and thus its rating is quite low, converter rating is quite low, the small converter, and thus price of this converter also low, and we can effectively control the power through this small converter. Another example may be actually simplified semi variable speed turbine. So, we may have actually rotor resistance squirrel cage generator varied instantly using the first power electronics control, and there basically this resistance can be controlled by this fire electronic circuit, but since you were actually increasing this resistance losses. So, previous one is more suitable for the wind energy application. This is decoupled from the grid, and we may have a, this is basically used for the permanent magnet synchronous generator, and or you may have a gearbox also. You take the power from the grid from the stator, and there the rectifier stage, because it may generate the voltage at any frequency which may not be suitable for practical applications. Ultimately, you have a AC to DC application followed by DC to AC application. And thereafter another application is definitely the system has a alternate energy sources and complementary energy resources in hybrid system. So, this will ensure power electronics ensure that it is a highly reliable system and at a reasonable cost, because we require to get a power from the solar at the rate of this actually the fossil fuels. So, for this reason actually cost has to be risen, and we require to put it in some place where solar is available, and for this reason there is a challenge of put it to, because if you are actually taking land for putting the solar plant, then actually habitat suffers. So, for this reason we should have a user friendly design to incorporate it. So, this is the example of the solar photovoltaic technology. Solar will be there, it will have a DC to AC conversion. This is a point of common coupling. This is where, and this is a filter that will actually filter out the high frequency ripple, and ultimately current can, once actually we will see that actually this grid power can be synchronized with the solar power, we close the switch and then power is transmitted. Solar electric, there is a few features of the solar market, and for this we require huge demand for the solar inverters, and thus the power electronics engineers. The solar electric energy growth is constantly 20 to 25% per annum over past 20 years. We have seen, especially now European Union has saturated, now it is turns to the actually the developing country like India, Bangladesh and all those countries to actually catch up this, and we should harvest as much as power from the solar. There is an increasing efficiency of the solar cell also, research is going on, and ultimately we get a solar cell with a higher efficiency. Manufacturing technology is improving nowadays, economics of scale is also increasing very fast. It implements actually IGBT technology, because it is in a level of actually 10 to 100 kilowatt. Inverter must be able to detect the sliding islanding, that is one of the features that is required, otherwise actually user can get a shock, because what happens if grid is removed, then due to the presence of the inductor and capacitance there might be an oscillation set into this actually grid, and ultimately solar inverter try to pump the energy in the open grid, and ultimately that when it is open circuit, then wave will be reflected back and may damage the inverter as well as the operator who is thought that actually grid is off. And for this reason actually we require to detect the islanding and will be stop working the solar inverter for the purpose of this actually maintenance situation, and take the appropriate measures in order to protect them, protect persons and the equipment. That is what the reason is. So, PV cells are connected to the grid, and PV cells isolated power supplies can be given. So, actually little bit of the power electronics were actually featured in total economy, worldwide economy, and main chunk now actually this is a US data. Of course, India centric data are not available, but we can dig it out and find it out actually the practical data. So, total electronics market is about actually 1000 billion, that is a quite huge chunk of money, and hardware electronics is basically, it is about 570 billion, and unfortunately you can see that this has a very low component of it, and we expect that huge catch up on this portion of it. So, power electronics is an enabling technology and component cell is just 30 billion. So, there is a huge gap in between this hardware electronics and the power electronics, and we believe that soon this gap will be merged and more contributions. Previous decade, actually decade of the communication. So, we had a mobile communications has been followed, and this is a part of the communication electronics. We believe that strongly that power electronics will actually contribute in a coming decade. We have efficiency now because of approaching around 100% using the soft switching and uses the switches of saturation mode on and off. On state resistance can be down to the tenths of ohm and are much smaller than the predecessors. High switching frequency means a smaller magnetic component, and with the invention of the actually SiC and the gallium arsenide devices, we can actually manufacture it for the higher frequency as well as high power densities. It reduces the losses and means actually smaller package and size, and that is very much suitable for the avionics industry, where they can cut down the operating cost if we can manage to reduce the weight of the flying object. The net effect is actually better efficiency, greater power density, and now actually we are looking for actually 5 watt per spark square inch is attainable. So, now actually let us talk about the growth of the power electronics. The technology boom of the semiconductor markets creates power devices with the significant power handling and the switching speed capability. This is for the ICs as well. The expanding the market demand for the new power electronics application that require the use of the variable speed drive, regulated power supply, robotics, uninterruptible power supply, etc., etc. The ever increasing demand for the small size and the lighter weight power electronic system. So, that system becomes compact and high power density. As a result of this increasing reliance on power electronic systems, made it mandatory that all such systems have radiated or conducted the magnetic interference, that is a problem of EMI EMC, and that may lead to this basically the communication error, and we require to suppress that. So, with the limited regulated ranges. So, what are the objective of this power electronics converter? Overall goal to produce a converter that performs well in the areas, actually it should have a high efficiency, very fast transient response, very fast load and line regulations, very high power density, very low input and output distortion, that means power factor as well as THD, very high reliability, or in terms of we define the reliability in terms of mean breakdown time. So, that is basically it is just like half life rates of the devices, and we try to increase and enhance the MTBF. So, that actually the many devices can last long. For example, if you have a transformer placed in front of you, that can be as old as 40 years. So, can we have a power electronics of that kind of reliability? So, that is a challenge that actually the present design engineers are facing, and we can replace then this actually bulky transformer with a solid state transformer. And of course, actually we are facing a cutthroat competitions, and thus we require to reduce the cost, and that becomes actually affordable to the many of the masses. So, in the final analysis, the job to process and control the flow of electric energy by supplying current and voltage in a form most suited to both the load and the energy source. This is basically the we want something from this power electronics. So, this is the and how you have done it we try to explain over in our classes. Now, what is the future trend of the power electronics? And so, continue with the technological development of high power and the high frequency semiconductor device like GAN devices or the SiC devices. We shall try to improve the energy density with the increasing efficiency and the performance. Improvement in the design of the driver circuits for the switching devices, that is DSP based driver or FPGA based driver may be featured in. Improvement in the control technique including the nonlinear control, adaptive control, sliding mode control or any other modern predictive control can be used to enhance the performance of the power electronics or the power electronics based system. Integration of the power electronics and control circuit in a single IC. So, this is the area of the embedded system, we are trying to do that, and this definitely distributed power system is an area that is evolving and it has got a really lot of challenges. Previously we had only consumer, then nowadays actually the consumer can be a producer. So, this change of this actually the criterion and that leads to the lot of control of the grid in locally, and thus we have a distributed power system. And also power electronics poses lot of threats because of the DC to AC rectification and all those things. Power factor correction techniques has been actually required to be incorporated, power factor as well as the THD minimization, and also we require to actually reduce the problem of the electromagnetic interference and radiations. A new power transmission concept has also evolved with the fax devices. So, these are actually future trend of the power electronics that we require to talk about. Thank you for your attentions. I hope that you find this course to be suitable for your practical application, students preparing for the actually competitive exam like GATE and other, and you will find this courses is very useful. Apart from the practicing engineer in the industry, also find this course to be very useful. Feel free to write in the forum, and we should be in a touch also in the interactive sessions. We are looking forward for a excellent course. Again, thanks for your support of team NPTEL. Thank you.